Okay, Bismillahirrahmanirrahim. Into the second segment of this June 2020 paper 3-1. We are into the P3 right now. Okay. We have done half this paper already. Acha says the diagram shows a circle with center O and radius R. Okay. The tangents to circle at A and B meet at A. Okay. Right angles have been marked. The angle AOB is 2x. The shaded region is bounded by the tangents. The area of the shaded region, okay, is equal to the area of the circle. Okay, the area of the shaded region is equal to the area of the circle. Acha. Now the shaded region is basically inside this kite. We don't have a direct formula to find the area of a kite, but we can divide this into two triangles, uh, congruent triangles. Okay, so you can see that this angle is now going to be x, and this is also going to be x, and you can write this side as r tan x using your trigonometrical skills here. Okay, this is r tan x. So area of the kite right now is going to be, since there are two triangles, 2 into half into r into r tan x. So this is the area of the triangle r square tan x. Okay, this is r square tan x, and we'll take out this sector out of this kite so that we are left with the shaded area. That is going to be minus half r square theta, that is 2x. ठीक है, is half r square 2x, and this is equal to the area of the circle, that is going to be pi r square. So you can see that this 2 is cancelled by this 2. Okay, and then by taking common you can later on cancel the r squares together. Okay, so we have tan x and minus x, that is equal to pi. So if you shift this x to the other side, you have shown what he was asking for, that is pi plus x. So that is how we show that this tan x is equal to pi plus x. Okay, let's move to the second part. Okay, it says the equation has roots um, in the interval this. Verify by calculation that the root lies between 1 and 1.4. So guys, this is basically heading towards the numerical solution of equations. So, this for this verification process, you have to write your equation in a way that all your terms, they are going to be on one side. This is minus pi minus x equal to 0. And you name this as f of x. So now you have to find f of x. Please find that keeping your calculator in radians mode. And then f of 1.4. Okay? So if one of them is positive, the other should be negative. And you will say that, look at the change of signs verifies that the root lies between 1 and 1.4. I believe you can do that. This is basically tan 1 minus pi minus 1. Okay, and then this is going to be tan 1.4 minus pi minus 1.4. So can someone tell me which one is positive, which one is negative? Hmm? So you see that by stating these values, you can tell that the change of sign, I'm not going to write that, okay? The change of sign verifies that the root lies between 1 and 1.4. Acha guys, iske baad he says use the iterative formula, uh, this to determine the root correct to two decimal places. Okay? So when you have to use that iterative formula, you always need to have the initial value. So what would be the initial value over here? Hmm? What will be your x1? Hmm? क्यों भाई? Any idea what will be x1 here? Hmm? if you go back to the previous part, it has asked you to verify that the root is between 1 and 1.4. So you have verified that as well. So then what should be your x1, bacho, for the iterative formula? Hmm? Okay, I'll not be marking attendance of anyone today. No one is willing to speak. Hmm? What is x1?
Sorry, 1.2.
Should that be 1.4 or 1? Hmm?
So where the 1 और 1.4 का average लेके बताया.
You can take that 1, okay? You can keep it as 1. That is your x1. Because uh, this is between 1 and 1.4. So you can start from 1, okay? So now your x2, you have to show this step here. Tan inverse of pi plus 1 here, okay? Put that in your calculator and tell me what do you get. Acha bhai, if you use your calculator appropriately, you will be getting these values, and finally you get your x to be as 1.35. Acha, moving to the next question number 7. Acha, this question number 7 is a straightforward question on u by v wali differentiation. Like if you have y is equal to u by v, your dy by dx is going to be v square vu dash minus uv dash. And if you want to score an A star in your exam, you must be working with a paper pencil right now with me. I'm telling you, bacho, you're taking this really for granted. Now this is your u equal to cos x and your v is equal to 1 plus sine x. Therefore, u dash would be minus sine x and v dash is going to be cos x. Acha, so let's find that f dash of x, that is v square here, that is 1 plus sine x whole square. Then you have v into u dash, that is going to be minus sine x minus u as it is into v dash, that is going to be cos x. Okay, so this is minus sine x minus sine square x minus cos square x over 1 plus sine x whole square. If I take a minus common from here in the next step, please forgive me for just skipping the steps. This would be plus. And you know that this would become plus 1, like sine square x plus cos square x is 1. So this is going to be minus sine x plus 1 over, I have taken again a minus common because this is 1. So if you take a minus common, so this would become minus into sine x plus 1 over 1 plus sine x whole square. You see that I can cancel them out like this, okay? So this is going to be minus 1 over 1 plus sine x. Now he says, show that f dash of x is negative for these values, okay? Let me show you where we are, what quadrants these are. Here it is your minus pi by 2, and when you go from this to this to this, this is from minus pi by 2 to 3 pi by 2. Okay, minus pi by 2 to 3 pi by 2. Acha bachcho, within this from minus pi by 2 to 3 pi by 2, the values of this denominator, they are going to be 1 plus sine x is going to be like at this minus pi by 2, this is going to be infinity, but this is not inclusive, okay? So this starts moving when you go towards 0, then you go to the pi by 2, then you go to the pi, and then you go to the 3 pi by 2. So here you have, this is going to be 1, and if I write it as minus 1 over 1, then this is going to be minus 1 over 2, this is minus 1 over 1, and here this approaches towards the minus infinity, okay, and here it is also minus infinity. So this means this has to be negative for all the values from minus pi by 2 to 3 pi by 2. But so please, you must ask me if there is anything that you have to ask, because बाद में ना कहना कि this the things were not clear. uh, Now how would you write that? You have to tell that 1 plus sine x is positive for uh, x to be between minus pi by 2 to 3 pi by 2. That is why this f dash of x is going to be negative, because negative into positive, the result is going to be negative. Now, we have to find the exact value of this simplified exact form. Now, a question on integration cannot be easier than this. Whenever you have a rational function, you have to see that if the denominator's derivative is there up in the numerator, so within one step, you can write this as limit from pi by 6 to pi by 2. This is ln 1 plus sine x. Got it, bacho? Because I have applied the rule here that integral of f dash of x over f of x is equal to ln f of x plus c. That is the rule I have applied here. If you have object, please do that. Now let's apply the limits. Ln 1 plus sine 90, that is sine 90 is 1, minus ln sine pi by 6 is half. Okay, so you have ln 2 minus ln 3 by 2. Can I write it as ln 2 minus ln 3 minus ln 2, है ना? If you remember that there is ln a plus ln b, it can be written as ln a, and then you can write its reverse as well. And if there is ln a, ln a minus ln b, you can write it as ln a over b, and then you can write it in this form as well. So that is why I have written it like this. ठीक है बच्चों, this is ln 2 minus ln 3 plus ln 2. Finally, this is going to be 2 ln 2 minus ln 3. You can leave up to this, and if you have a better taste of logarithms, you can write it as ln 4 minus ln 3. And you can even write it as ln 4 over 3. Let's see where up to what the examiner has. Oh, he has given the answer as ln 4 by 3. Look at this here. So we have written this as ln 4 over 3 as well. Okay, so he could have told us to write the answer as a single logarithm. Anyhow, so this is your B part. Okay, and then we are on to question number 8. Okay, a certain curve is such that its gradient uh, is proportional. Now, gradient, you can immediately write dy by dx is proportional, is k times y over x under root x. The curve passes through these 2 points. By setting up blah blah blah, we will find y in terms of x. So, did you see how I wrote this equation here? He said gradient. So you know the gradient at this point, that means dy by dx. Proportional ke liye, I have put that k over here to this. Okay. Now we start solving this equation. So this is going to be dy over y, that is equal to k dx over, let me multiply them and write it as x is to power 1.5 or 3 by 2. Okay. and then you put the integration sign here. You know that the integral of ln y is, sorry, 1 over y is ln y. And you can write this as k x raised to power minus 3 by 2 dx. So this is k x raised to power, now minus 3 by 2 plus 1 is going to be minus half over minus half plus c. This gives you ln y equal to minus 2k over under root x plus c. Now let's put these points here. We'll have two equations in x and y, and we'll get to that required equation. First of all, I'm going to put that 1 1. So I have ln 1 equal to minus 2k plus c. So this c is going to be equal to 2k. That is my first equation, because ln 1 is 0, we know that. Okay. Then we put the second point, ln 4 is equal to minus 2k over uh, under root e, or under root e. And then now here is he's going to grind you people here, okay? And then you have plus c over here. Okay, now let's write 2k instead of this plus c. So we have ln 4, that is minus 2k over under root e plus.
X coordinate
Hmm?
4.
Yes?
X coordinate 4.
Oh, I have written this. I was thinking the same, that how can he grind us like this? Okay, thanks a lot, beta. I was making a big mistake here. So ln E is 1. Thank you for saving us from the disaster. Okay. Thank you, beta. This happens when you people are alert, okay? So this is going to be 1, this is going to be 2, and this is going to be 2k. Okay? So we have 4k minus 2k equal to 2. So 2 is equal to 2k. So your k is 1. When your k is 1, then your c is 2. Therefore, your equation is now ln y is equal to uh, minus 2 over under root x plus 2. Okay? And in one step, we can say that y is equal to e raised to power minus 2 over under root x plus 2. Let me check the answer. Yeah, this is absolutely right. And thanks to that student who intervened the right time and saved us from wasting a lot of time. Okay, now let's see what is there in the second part. So this was again a straightforward question, okay? Now let's see what's there in the second part. Describe what happens to y as x tends to infinity. As x tends to infinity. Okay, we can use this relation here instead of this. Now, when x tends to infinity, bacho, can I say that this thing will be equal to 0? Hmm? Or this thing will be 0 when x tends to infinity? Hmm? Anna? So when x tends to infinity, your y would tend to e square. Y would be, let me check the answer. Y would be, where is that? Yeah, this is e square. Y would be e square. Do you agree with this, Bacho? This is the answer to this B part. When x tends to infinity, anything over infinity is going to be 0. So 2 over infinity is 0. So you're left with e square. So y is going to be e square. Okay?